Hello, good morning. We're going to continue with lecture 10 today. We probably will be able to finish the whole thing. So last time we learned pretty much the names of the important bones, right? Starting from the skull, and then we move our way down to the chest, to the arms, and to the legs. And you should have a pretty good understanding of how the bones connect and the different sockets that they form, as well as some of the names of the key bones that we have in different parts of the body. So we will start today's lesson with the joints as well as the shapes of the bone in terms of how we classify them. So let's start with the shape. We can classify bones based on how long they are. And example of long bones would be something that's relatively like rectangular in size. It doesn't have to be long. This is also classified as like a long bone, something like that. As long as the dimension is relatively rectangular, then typically we call it a long bone. Can we have some examples of long bone, please, based on the ones that you've learned from last class? Anybody?
Ulna, radius, femur.
Yeah, you got a bunch of them. That's good. Ulna, radius, femur. Okay, humerus as well, right? So all those are examples of long bone, and here it says such as those in the arm. Flat are mostly for the ones that are in the head. So we have parietal bone. Okay, maybe one more. Anything you remember from the head?
Temporal bone.
Sure, yeah. So these are relatively flat, like a piece of chips, if you would. Short bone would be things like, phalanges in the hand and the foot. Oh, it says right here. I didn't even see that. And the tarsals are more, they classify that as long bone in some cases. Again, the ones that I give you on the quiz or on the test, they're going to be clear cut. Okay, I'm not going to try to trick you and give you something that's seemingly in between. It's going to be very obvious. If things don't fit in other categories, then it's going to be like an irregular. If it looks kind of weird, then it's irregular. So the ones that makes up the backbone, the spine, those are the vertebra, right? Vertebra. Do you guys remember any other bone that looks kind of weird in the body? Doesn't really fit in any other categories. If we keep on following the spine down, eventually we hit something that looks really strange. What is the name of that?
Coccyx, was it?
The coccyx are the tail bones, right? So those are little bits like that. There is something that looks more weird on top of that. Do you guys remember? Here, let me pull it up for you. Right? Like this thing looks pretty strange, right? So like, it has holes in it, and it's kind of irregular all over the place, right? So that's the sacrum. Sacrum. And another one, maybe one that's in the skull that looks a little bit, again, out of place. It's not long, it's not short, it's not flat. Anybody remember that one? It's the one where all other bones in the head connects to. It has a little groove at the top for the pituitary gland to sit in.
Mastoid process.
That would be like right here at the back of the temporal bone. The one I'm looking for is the sphenoid bone. Okay. I mean, it's okay. Like you guys have your kidney quiz today, so you probably didn't have time to look through these things. But you know, when you have time, you should go through the bones we learn and try to classify them one way or the other. Okay. Next, oh, sorry, that's just another slide that shows you, examples of flat bones, irregular bones, and other stuff. Okay, next we're going to talk about joints. Joints are basically where two bones connect with each other. And another name for joints is articulations. And we have 6 types of movable joints. So these joints allow us to create wide ranges of motions. So the first example is what we call a pivot joint. Okay, so pivot joint allows us to rotate about 180 degrees. And the example of pivot joint is the atlas and the axis. Atlas and axis are also known as C1 and C2, right? Those are the two cervical bones that is at the beginning, at the top part of your spine. Okay, so you might remember, I'm just going to go back to show you that C1 and C2 forms the pivot joint by having the adenoid process of the C2 protruding through the central foramen of C1. So it creates this, pivoting joint that allows us to basically shake our heads. Okay, so that is pivot. Next one is saddle, saddle joint. Saddle joint exists between the carpals and the metacarpals. Metacarpals are the bones at the back of your hand, and the carpals are the egg bones that are at the wrist. So they form a saddle joint. Saddle joint allows like small motion like this. Right? It kind of allows you to move the wrist in a not as wide of a range, but kind of just shallow back and forth rotation. Then we have gliding joints that exist between the carpals. Okay, I'll show you a picture of what they look like. Condyle joints exist also in the metacarpals and the phalanges. So there are a lot of different types of joints in the hand. But you might remember seeing this word before, right? The occipital bone, the bone that at the back of your skull, beside the foramen magnum, there are 2 condyle joints that forms an articulation with C1, and that allows you to nod the head. So these ones are a little bit hard to visualize, these 3, because we're not familiar with, how they look. But the next 2 should be relatively straightforward. There's a hinge joint. The easiest one to know is the elbow. A hinge creates these kind of motion like the door hinge. And then ball and socket. Right, so at the shoulder and at the hip. So last time we talked about the shoulder, there is the scapula, which is your shoulder blade, right? There is a socket on the side called the glenoid cavity, and then your humerus is able to fit into it. And for the hip, there is the acetabulum, where the head of the femur is going to fit in as well. Now, if these things sounds very unfamiliar to you, you can look back at the slides from last time to take a closer look. Let me see where the hand is. There it is, right? So I showed you on the 3D model, right? That if you remove this head here, that's the head of the humerus, right? There is going to be a process right there, not a process, sorry, a cavity, right? For you to create the ball and socket joint, and that's part of your scapula. And similarly, last time at the end, we talked about the acetabulum, and that is where you would insert the head of the femur into it. Okay, so those are both ball and socket joint. It's very straightforward in terms of the test questions for these kind of things. I will ask you which of the following is an example of like a pivot joint, right? So as long as you have these examples, I'm not going to give you examples you've never seen before. Okay. So this is just to show you what they look like. If you want to visualize how they appear to be. Okay. In addition to movable joints, we also have partially movable joints. Partially movable joints have very limited range of motion, and you will find them at the backbone. So this is the vertebrae. Okay. Between each of the backbone, you know it's made up of 7 in the neck, 12 in the chest, and so on and so forth, right? So between each of the vertebra, the range of motion is very limited. Okay. But if you have a whole stack collectively, that allows you to bend forward, right, and then bend backwards. So it's to stabilize the spine. You can think of like a whole stack of chairs. If you stack 2 chairs on top of each other, it's very limited motion. But if you keep on stacking, when it gets higher and higher and higher, eventually like you can move the whole column, right? That's essentially what it's like for our backbone. Okay, so that's partially movable joints. And then there are immovable joints. Immovable joints are they, as the name implies, they don't create any kind of motion. So you will find them in the sutures in the head. Okay, so these lines, that's where the bones join together, right? During embryonic development, your body slowly convert the cartilage into the bones, right? During the process called ossification. And I told you when the baby is born, the head is not fully ossified yet, right? It's still kind of flexible. But as we grow, those cartilage are going to be replaced by calcium, and ultimately they will form these sutures, and then it will be the immovable joints. Okay, so 6 types of movable joints. I give you an example of a partially movable joint. I mean, there are others as well. And then there are the immovable joints. Okay, let's take a look at these questions. Very simple, very straightforward. Let's see if you can answer them. Yeah, all the people who participated got the right answer. This is a pivot joint. Pivot joint. Okay. Now this one is from last time. I think I'll do this one for you. It's unlikely you guys remember because again you're focusing on the kidney test, right? So that's the acetabulum here on the side of the coxal bone, and that is made up of 3 bones: the ilium, the ischium, as well as the pubis. They all kind of contribute to this socket. All right. So pubis, ilium, and ischium. And again, just to write down forms, ball and socket. Join. With femur. All right, one more. Select all the long bones. All the long bones. All the long bones. Okay, thank you. There is a humerus, yes. Metacarpals, that's also, I mean, that one is a little bit unclear, right? I said, but metacarpals are also considered as long bones. Sternum is flat. Okay, tibia, for sure. So ABD. Okay. Okay, let's take a look at this thing here. I'll explain it first, and then we'll take a note for it. Now, we are moving, we kind of building up to the last lecture of the course, which has to do with hormones. Okay, and there are a lot of hormones we have to cover. And along the way, we will learn a 3 pairs of what's called antagonistic hormone. Okay. Antagonistic hormones, they have opposite effect. Okay, opposite effect. And they often work against each other to help maintain some kind of homeostasis. Okay, opposite effect, work against each other to maintain homeostasis. We actually learned a pair of antagonistic hormones already in the kidneys. Okay. There is aldosterone and there's ANH. Okay, you should know those because it's on your quiz today, right? So ANH is going to help bring your blood pressure back down, while aldosterone is going to bring the blood pressure back up. Okay, so they work in different ways, opposite ways, but together they will keep the blood pressure within homeostatic range. So we're going to learn another pair today. It's called the calcitonin and PTH. So we need to have normal blood calcium level. Okay. Too much calcium in the blood, as you will see, is actually going to cause your muscle to twitch involuntarily. And then if it's too low, you might experience things like muscle weakness. And we also need to have the right blood calcium level so that, the charge across the membrane of the cells are going to be normal. Yeah? So basically, too high or too low is no good. So we need to keep it in just the right level. So let's say your blood calcium level went up for whatever reason. Okay, maybe you are taking calcium supplements. So we don't want the calcium to stay in the blood. We want to absorb it. Right? So that high calcium level is going to trigger the thyroid gland to release calcitonin. Thyroid is right here. Okay, don't confuse the thyroid with the thymus. Okay, thymus is the lymphatic organ, right, where the T cells mature. This is the thyroid. So the thyroid gland is going to release the calcitonin. So the way I remember it is when calcium increases in the blood, we need calcitonin. Okay. When there's a calcium increase in the blood, we need calcitonin. So what does the calcitonin do? It will stimulate calcium deposition in the bone, which totally makes sense. You have all these extra calcium in the blood. Where else are we going to put it? You're going to put it in the bones. Bones is where you store them, right? And at the same time, calcitonin is going to reduce calcium uptake in the kidney. Okay, we don't need to keep the calcium anymore. So, you know, when the filtrate passes through the proximal tubule, the distal tubule in collecting duct, we don't need to absorb the calcium. Just let it go out of the body. Right, so together, this will bring the calcium level back down. On the other hand, if calcium level drops, if you don't have enough calcium, then there is another gland that will respond to this. So like if you pull the thyroid out, on the back of the thyroid, there is going to be 4 glands. They are collectively known as the parathyroid gland. Parathyroid gland. They kind of piggyback on the back side of the thyroid. And the parathyroid gland releases the parathyroid hormone, PTH. So PTH is antagonistic to calcitonin. They do the opposite things. So they will stimulate calcium release from the bones. We don't have enough calcium in the blood. Let's take it from the bone. We'll tell the kidney to reabsorb more calcium. And at the same time, it will tell the intestinal tract to absorb more calcium if they're available, right? So these things will hopefully bring the blood calcium level back up. Okay. Now, in your study guide, there is a chart. And we actually have a lot of these hormone charts that are coming your way. If you watch the lecture 9 study guide tutorial, you will notice there was also hormone chart for aldosterone, ANH, and ADH. I didn't have time to take those up in class with you. But if you watch the videos or if you look at the study guide answers, you will notice there was a table. So I want to fill this table in with you just to help you, organize the thoughts a little bit. So here we have 2 hormones, and we want to talk about the location of secretion. Where is it coming from? And hormones are secreted by endocrine glands, and they go directly into the bloodstream. So calcitonin, it's secreted from the thyroid gland. Thyroid. That's the one that gets big, right? When you don't have enough iodine, you might remember that. Calcitonin. Stimulus. High blood calcium. Again, when there's a calcium increase, you need calcitonin to bring it back down. What does it do? Deposit calcium into bone. Reduce calcium uptake in kidney. Okay, you're just gonna pee it out, the excess. We don't need them. Let it go out. That's all. Okay. So try to keep it simple for these things so you can remember them. Okay. And you should start memorizing the hormones. I'm not exaggerating. We have over 20 hormones we need to learn in the next 2 weeks. And you can organize them into these charts. And I will help you fill them out along the way and try to help you make sense of it all. So next we have the parathyroid gland secreting the parathyroid hormone. Parathyroid gland. Okay, so the thyroid is like this, right? Thyroid. It looks like, I don't know, a bow tie. Okay, so this is from the front, anterior view. And then at the back, you're gonna have 4 little knobs. Those are the parathyroid glands. So the stimulus is going to be low calcium level. in the blood, low blood calcium. You don't have enough. So where are you going to get the calcium from? Okay. Releases calcium from bone. And you can understand why if you chronically lack calcium in the blood, because you're not taking supplements, you're not, drinking enough milk or eating other calcium-rich food, then your body will just keep on taking the calcium from the bones. And the bones get weaker and weaker over time. And that's how people might end up having osteoporosis, right? So that's from the body. But you will also be able to increases calcium uptake from kidneys and intestine. Okay, so you try to absorb more from the food. Every little bit counts. And then you try to minimize loss through the urine by telling the kidney to absorb it back, right? Does anybody have any question?
Sorry, it minimizes loss through. I didn't get the last part.
Through urine. Yeah, urine.
Okay.
Yeah, because in the kidney, in the filtrate, if you don't take whatever you don't take back, you're just gonna pee it out, right? So you wanna tell the kidney to absorb as much calcium as possible to minimize loss. Okay.
I have a question.
Yeah.
For the mother pregnant, she need more calcium for the skeletal baby. All of the calcium come from intestine, kidney, and bone.
Well, the mother would ideally the mother would be on supplements, right, during pregnancy, and that would increase the available calcium. And you're right, a lot of the calcium does go to the baby, right? So if the mother does not have enough calcium in her own diet, then her bone is gonna get weakened. So that's why people say, if you're trying to get pregnant, then get on the prenatal supplements, right? And then even afterwards, right? You want to be on those supplements as well to boost up, amongst other things, right? Like calcium.
Thank you.
Yeah. So this is just to show you again where the thyroid gland is. That's the front view, and in the back you have the parathyroid. Okay, that's your trachea. That's your larynx, right? A little bit below that. That's where the thyroid is gonna be. Osteoporosis, this is the normal spongy bone. Spongy bone, you might remember, is we drew the compact bone last time, right? But as you move towards the center of the long bone, as you get closer and closer to where the bone marrow is, they kind of transition into the spongy bone, right? So it's normal to have some spongy bone, but then in osteoporosis, you can see the spongy bone gets like extra spongy, I suppose, like more there are like a lot of holes in it within the bony structure, and that cause it to become very very brittle. That's why preventing fall is very important for elderly, because if the bone is already weakened, and it's sometimes there's only so much you can do, even if you do all the right things, take all the calcium pills and stuff like that, do strength exercise, it's inevitable that our bone gets weaker as we age. Okay, and sometimes if they are so brittle, and a fall could like shatter a hip or something like that, and that would you know um, be a very debilitating, right? Okay, there's another condition called rickets. And again, if you have kids, you would know. They recommend you giving kids vitamin D, and it comes with these they call it D drops. Okay, it's supposed to give them a drop every day to supply vitamin D. So vitamin D is actually necessary for your body to absorb calcium. Okay, and normally your body makes vitamin D, but it needs sunshine. Uh, we live in the northern hemisphere, and during the winter months, there's not enough sunshine, right? And so we don't get enough vitamin D made in the body, and therefore we don't absorb enough calcium. So by taking the vitamin D drop, we kind of supplement for that process. And kids who don't have enough vitamin D and therefore don't have enough calcium is going to sometimes get this condition called rickets, especially when they start to learn how to walk. The bones are too soft because of the lack of calcium. And as soon as they start walking, the body weight presses on the legs and it causes the legs to become bowl shaped. So this is called rickets. Okay, let's see if you've learned anything from the chart that we just fill in together. When blood calcium is low, which of the following is true? Okay, well, all you have to do is look at the chart. Low calcium, stimulus means trigger, right? So low calcium is going to trigger PTH to be released. So the answer is D. The parathyroid secretes parathyroid hormone, PTH. Let's do one more. Okay, good. So high level of calcitonin. Remember, calcitonin's job is to bring the calcium level back down when it's too high. So where are you gonna put the calcium? You're gonna put it in the bones, right? So increase calcium deposition in the bone. All right. So someone chose B. It says decrease filtrate calcium level. No, it should be increase filtrate calcium level because you gotta get rid of the calcium, right? Through the urine in this case. Okay, that's all. That's it for bones. Any questions before we move on to the muscle? Anything at all? Quiz today, right? You remember? Like 2 attempts. Make sure you do that. We won't be long. It's we only have like what is this? Like about 20 slides to go and then we're done. So you'll have plenty of time to do your quiz. All right, let's do muscle. What does muscle do? Functions of skeletal muscles. Well, they support the
Excuse me.
body. Yeah. Go ahead.
So sorry.
No.
For quiz, each attempt is better. You count that one.
Sorry, each attempt there is what?
Each attempt it's going better. You count that one. It's better. That better.
Yeah, the best one. The best one. Yeah.
Best one.
Yeah.
Yeah. Thank you.
Yeah.
Thank you.
So support the body. Even you're sitting right now and it doesn't feel like you're, contracting any muscle, but actually your back muscle, especially the lower back and the shoulder muscle, they are constantly contracting, right? So to support your body so that you can sit up straight and not like slouch over. Okay, so those muscle has to kind of work throughout the day. That's why like people say, "Oh, I'm so tired. I've been sitting all day." It's actually true. If you sit all day, the lower back is very straining because it keeps on contracting, right? To support your body weight. Make bones and other body part moves. When the bicep contracts, it pulls on the radius and the ulnar, right? And then it allows you to flex your joint. Maintain a constant body temperature. When you are cold, how does the muscle help you keep warm? What is the one thing that they do for your body when you're cold? No? A little bit surprised here. It's when you're cold, your body shivers, right? Shivering is basically muscle contraction, and the shivering produces heat, keeps you warm. They assist fluid movement in cardiovascular and lymphatic vessels by moving the legs, for example. It helps with venous return. We learned that a lifetime ago in Unit 1. Protects bones and internal organs and stabilizes joint. Okay, so because the muscle is on top of the bone, it protects the bones as well. All right, let's draw another picture, and this is a bit difficult to draw. This is even more difficult to draw than than the bone stuff. So here we go. Class notes. What? Oh, April now, eh? April 1st. All right. So some highlighters would be ideal if you have them, or markers. So this is called muscle organization. Okay, so let's say there's the bone, right? This is the bone. Again, sideway, please. We're gonna start here, and then I'm gonna keep on, keep on pulling things out like that. So this is the bone. Okay, and then there is gonna be like a tendon here that connects it to a muscle. This is the muscle. That's a tendon. This is bone. And then this is muscle. Muscle has band patterns on it, right? So that's like another tendon connecting to another end. Okay, so I'll give you a moment to catch up first. Right, this would be like another bone, right? Another bone. And then maybe like it forms a joint or something. You don't have to draw the bone. I'm just showing you. So the tendon connects the muscle to the bone. So what we're gonna do is we're gonna basically like cut the muscle open, cut it open, and then we're gonna take a look at it. And this is where it gets a little bit difficult to draw. So here we go. Let me try it one more time. There we go. There is the muscle. So that again is the tendon. And then this is the muscle. And then when we cut it open. Now, the entire muscle is actually surrounded by a connective tissue. So all this whole muscle is connected by a connective tissue. So we're just gonna color it. And we call that connective tissue the epimysium. Epimysium. It is connective tissue that surrounds the entire muscle. Okay. Sometimes you see it when you buy meat. Like there's this like membrane, almost like a membrane, transparent membrane thing that you can peel off, like the chicken breast or something. Okay. Or like if you eat ribs, you can peel that layer off. That's the epimysium. Covers the entire muscle. Okay, now this next part is a little bit tricky. If you look at the muscle, like the cross section of muscle, you actually will see little bundles like that. And again, I know not everybody eat meat, which is fine. But like if you eat meat, and you cut the beef, how did they say to cut the beef so that it's not too chewy? What's the advice for cutting the beef? Does anybody know what I'm talking about? Do you ever hear people say cut against the grain? Does that mean anything to anybody here? Cut against the grain? Like you buy a piece of meat and then you can see the pattern. And those are the grain, right? Like if you cut parallel to it, then it's going to be really chewy. But if you cut against the grain, if you cut perpendicular, like, put your knife like that, and then cut it this way, then you're cutting against the grain, right? Then it's gonna make the meat less chewy. So when you cut it like that and you look at the cross section, you will see these little bundles, and actually you can pull them out, which is what we're gonna do. We're gonna pull one out. We're gonna enlarge it like that. Okay, and again, if you eat like a pulled pork sandwich or something like that, okay, the strands of the meat, that's this thing, essentially. So what is this thing? Well, this thing that we just pull out, that is called a muscle fascicle. Muscle fascicle. So the epimysium surrounds the entire muscle, and then the muscle is made up of a bunch of these muscle fascicle. So that's a muscle fascicle, that's a muscle fascicle, that's a muscle fascicle. I just pull one out to show you, right? Now, the muscle fascicle is also surrounded by its own layer of connective tissue. So we'll say surrounded by the perimysium. Okay. So again, it's connective tissue. I'm not gonna rewrite that. It should make sense to you. Which means like immediately underneath the epimysium, you will be able to see this one has the perimysium. This one has the perimysium. Each of them is like surrounded. Each of the fascicle is surrounded by its own connective tissue, right? The perimysium. All right. There you go. Now, every now and then, you're gonna have a little bit of these blood vessels. And also, of course, you're gonna have some nerves, these nerve endings. Okay, so I'm just gonna pause for a second and you know, let you catch up, and let me know if you have any questions. Anything at all so far? Am I making sense here? Okay, well, what is inside the fascicle? You probably see where this is going, eh? The fascicle is gonna have its own bunch of circles. And you know, we can pull another one out. And pull another one out like this. And we just gotta pull out a couple more times, and then we'll be done. This here is a muscle fiber. Okay, which actually is another word for muscle cell. Okay, so a fascicle, a muscle fascicle, now we know is a bundle of muscle fiber. A bundle of muscle fibers. And each muscle fiber is surrounded by, so that's muscle fiber, all these are muscle fiber, okay? Each muscle fibers are surrounded by yet another layer of connective tissue. And they're called endomysium. So here we go. We're going to color this endomysium. And of course, so are each one of these. That's going to be the endomysium around, surrounding them, surrounding them, surrounding them. Like that. I guess one way to think about this is like this, okay? Like a box of crayon. The individual crayons, right? Like the individual crayon here, that's like a muscle fiber. And the paper wrapping that goes around the crayon, that would be like the endomysium. Okay, endomysium. And now you take a bunch of crayon, pack them together in a whole package. In this analogy, can someone tell me what does the whole box of crayon represent? What would this represent? Okay, like each of the crayon is like a muscle fiber. What would the whole pack of crayon be analogous to?
The tendon?
Muscle fascicle.
That's right, the muscle fascicle. Okay, right, not the tendon. Tendon is like all the way out. Okay? But this would be a muscle fascicle. Look over here. Can you see my mouse? You should be able to. So this is the crayon, this is the muscle fiber, and you put a bunch of them and you get a bundle of it, then that's like the purple thing right here, right? That's the muscle fascicle. Okay, you can put a shrink wrap around this thing, like those plastic cell wrapping, then that would be like the paramecium. Okay. Now, hold on a second. Let me just get another picture from Amazon here. I don't know if this is helping or not. Let's say you buy in bulk, right? Then you take a bunch of these, fascicle, and then you put it into a huge box, right? Like the whole box here. Then the whole box is like the muscle. Okay? The muscle, if you open it up, it's basically a bunch of these muscle fascicle. And if I take out one of those packets of crayons, I have the individual crayons. It's just a layer within the layer within the layer, right? Is that okay? Like, ask me something. I don't know, you guys are super quiet. I actually have no idea if you're with me or not. Anything you want to ask so I can clarify for you? Or are you good? Okay. Unfortunately, oh, thank you. Unfortunately, this is not the end of the story. Okay. This is not the end of the story. The muscle fiber, the individual muscle cells, actually also have more things in it. More things in it. This is the last time, okay? And then we can take out one of these things as well. Okay, we can take out one of these things as well. So these are called myofibrils. Myofibrils. Okay, myofibrils. And they are the contractile fiber of muscle cell. These are the things that allows the muscle to contract. Okay. And it's made up of these repeating units. These repeating units called sarcomere, which I'll explain in a bit. Okay, but then they have these like banding patterns on them. Okay, so it's made up of these repeating units called the sarcomere. which are made up of myosin and actin proteins. Okay. Now, one last thing. The myofibrils are surrounded by something called the sarcoplasmic. I should use a different color. Surrounded by sarcoplasmic reticulum. Which are basically endoplasmic reticulum, but of the muscle cell. Okay. So let me quickly go through this with you. It's like more info for muscle fiber. More info on muscle fiber. Remember, muscle fiber is basically a muscle cell. So here it is. Here it is. This is a muscle fiber. And of course, the muscle fiber has a cell membrane, right? Just like any other cell. So let me draw the cell membrane for you. I'm just gonna use pink maybe. Maybe take a look at what I'm doing first before you do it. I'm not gonna color the whole thing. I'm just gonna color half of it. Okay, so this is the cell membrane. Cell membrane, but we have a special name for it. Okay, cell membrane is called the everything is sarco here, okay? Sarcoplasmic reticulum, sarcolama. Sarcolama. And outside of the sarcolama is basically this thing. Okay. The endomysium. This is the endomysium, which is like the thing that goes around the muscle fiber, right? This green part right here, right? So if you kind of roll that out, roll that away, then immediately you would see the cell membrane, okay, or the sarcolama. Now we already know, I told you, inside there are more of these myofibrils, right? These are the myofibrils, the ones that are actually going to be doing the contraction. So if I just draw one of these fibrils inside the cell like this, and I know it's getting confusing, so maybe you can watch, or you can draw if you want. These myofibrils are surrounded by the membranes, the endoplasmic reticulum. So those are sarcoplasmic reticulum. Okay. And what you have to know about these things is they contain calcium ions. Contain calcium ions. And there are actually tubes that connects the sarcoplasmic reticulum to each other. And these tubes go all the way to the surface of the cell. Okay. Connects to the surface of the cell where there is like an opening. I'm gonna go back to these opening later on. But finally, these tubes, they are called T-tubules. T-tubules. Okay, I'm just showing you the names first. I'll explain what they do in a bit. And that's the organization. Remember, this is a cell. This whole thing is a muscle cell. A muscle fiber is muscle cell. It's very long. You're gonna find all the usual stuff, the mitochondria, you know, a bunch of other stuff, Golgi bodies and whatnot. Okay? So that's the organization of the muscle. Now, let's just make sure that we are on the same page here. This is a study guide. I know you guys have it. So here it is, right? This is the thing we just drew. We cut the muscle. This is the tendon that connects muscle to bone. And then that's the whole muscle. Now tell me, please tell me, what is this? I am not sure if I can use the same color. I don't remember what I used. But what would this whole thing be? Right here. This thing. What is that?
Perimysium.
Yes, that's the membrane that surrounds it. But I'm thinking about that whole thing. The whole,
Muscle fascicle?
that is the muscle fascicle. Very good. Muscle fascicle. Okay, but Mix, you're right. This is surrounded by the perimysium. Okay, again, I'm sorry if I'm not using the same color as the picture, but that's what it is. Okay, go. Sorry. So that's the perimysium. All right. Now, what about this? What about this this thing right here? This whole thing. What is that?
Epimysium.
That is the epimysium. Yes, very good. And you can see, right? That's the outer one, right? That's the outer one right there. Okay, so that's what you I mean, hopefully all of you understood the diagram, but I want you to, you know, go through this yourself when you have time, and just to make sure that you are able to label all the parts. And you know, there is an other muscle fascicle there, and then another muscle fascicle, so on and so forth. And just very quickly, this guy right here, right, that's the muscle fiber, the muscle cell, and then that here is the myofibril. All right, that's all. Now this tells you what it is surrounded by and what it contains. I'll show you the PowerPoint slides so you know where to find it. It's basically all here, right? So let's just go through it one more time. The skeletal muscle is the whole muscle. It's surrounded by the epimysium, and it can the muscle fiber, the whole muscle contains muscle fascicle. Fascicle. You take a fascicle out, you can see it's surrounded by the perimysium. And then it contains the muscle fibers. Right? All these are muscle fibers. And if you pull a muscle fiber out, right? The square here tells you what you're pulling out, right? So you pull out a muscle fascicle, you will see the endomysium, this stuff, and then it contains the myofibril. And remember, this cell membrane right here that they did not label, cell membrane, which is called sarcolemma. Okay, sarcolemma. And then we have the myofibril here. And this blue stuff, that's the sarcoplasmic reticulum. Again, the key thing to know is that it contains calcium. And finally, the myofibril is repeating units of these things called sarcomere, which I haven't tell you what they do yet, but they produce contraction, to keep it simple. Okay? And it contains two things. It contains the thick filament, which is the myosin that I told you about. And then the thin filament are the actin. Okay. All right, moving on. This is just show you the cell again. Not sure why there is a white box there. Just delete that. So, that's all the structure we talk about, right? There's the sarcolemma, the cell membrane, the sarcoplasm, which you probably can translate into cytoplasm. And you can see the T tubules, which are all these yellow network. It goes all the way to the surface, and there's like a hole there. Okay, and that's important for later. So those are the T tubules, and then you basically have a network that wraps around the myofibril. Okay, so we spent a lot of time on this. Hopefully you're with me. I'm just gonna skip the break. We probably can plow through the rest of the slides. 20 minutes. The hardest part is over. Okay, question. The fascicle is covered by, you probably are sick of hearing me talking about this already, so I'm just gonna move it along. The fascicle is surrounded by the perimysium. Perimysium. What does a fascicle contain? Well, the fascicle contains muscle fibers, right? You just have to look at that slide and you will be okay. All right, let's take a closer look at the myofibrils. Each myofibril is about 1 micrometer in diameter. 1 micrometer is 10 to the negative 6 meter. It's a millionth of a meter, very fine structure. And they are composed of numerous sarcomeres joined end to end. The sarcomere is the contractile unit of muscle. Your muscle is able to contract because of the individual sarcomere. They're connected end to end and they keep on repeating. It has two kinds of protein in it. The thick one is the myosin. These things have heads on them. And then the thin ones are made up of 3 proteins. I told you about the actins already. There are other ones, tropomyosin and troponin. So let me explain to you, how it works, and then I'll give you some notes on it. All right. So basically, on the left picture here, we have the actin filament. The actins are, you learned actins last semester, right? They are the cytoskeleton. They are made up of these circular protein subunits. And shown here is like little red balls, okay? Now the actin, right here, actin has a binding site for myosin. Okay. Myosins are these proteins. It's not showing. It is showing down here. The myosin looks like this. Okay. The myosin has a little arm that will grab onto the actin. Okay, it will grab onto the actin, and then it will pull on the actin. But in order to grab onto the actin has to expose the binding site for myosin, which are these little brown circles, black circles. Okay, but normally when your muscle is not contracting, the binding sites are covered up by tropomyosin. Tropomyosin. So this thing covers up the binding site. Okay. The green strand covers up all the binding site. And when they're covered up, myosin cannot grab on to the actin. The positioning of the tropomyosin is controlled by the troponin. Troponin controls the position of tropomyosin. Okay. Troponin level actually goes up in the blood if someone suffered from a heart attack. That's actually one of the things they check in the blood to see whether you actually have a cardiac event. Okay, so let's recap. We have the let me show you the next slide first so that you have a better understanding. Over here, these this is a sarcomere, okay, from one end. Never mind the A band, I band, Z line. Okay, I'm not going to test you on those things, but this whole thing, that's a sarcomere. Okay, the red are the actin, and the blue are the myosin, the thick and the thin. The myosin have heads at the end over there, and what will happen? Like if you think of me as the myosin is gonna grab onto the actin on top and below, grab it on, and then it's gonna pull inward. It's gonna let go and grab again and pull, let go and grab and pull. So by pulling, what's gonna happen is you are shortening. You're shortening the sarcomere. When you shorten the sarcomere, the entire muscle fiber becomes shorter. And that creates a pulling force, which results in muscle contraction. Okay? So that's what you're trying to achieve here. You want the myosin to grab onto the actin and pull so you can create contraction. But right now, it's not happening because the binding sites are covered up by the tropomyosin, and the positioning of the tropomyosin is controlled by the troponin. Okay? So how do you get this thing to go out of the way? Well, you're going to need calcium. When calcium arrives, and I'm going to tell you how the calcium comes. When calcium arrives, the calcium will bind to the troponin, which will roll away the tropomyosin and expose the binding site. Once the binding sites are exposed, then the following can happen. The myosin head will split an ATP, and that will help reset its position. Then it will grab onto the actin, forming what's called a cross bridge. And then the ADP will fall off, and that allows the myosin to grab on and pull. And then the ATP will come and help detach. Okay, you don't really have to know the details here. Okay? All you have to know is that the myosin grabs onto the actin and pull, and that creates contraction. But the process requires ATP. Okay? The ATP is there to help release the grab. Okay, so again, the myosin grab on and pull, but then you need to release and grab onto a new site, right? If you grab and pull and don't release, then the muscle stiffens up and creates no contraction. You might have heard of rigor mortis, which is the stiffening of the muscle when a person dies. When a person dies, there's no ATP. No ATP, the muscle cannot relax. Okay, it grabs on, the myosin grabs onto the actin, it stays there, doesn't spring back, and that creates the stiffening. Okay, so that's
Sorry.
yeah.
Is that why like dead people are heavier? Because the muscles not relaxed?
I don't know if they are heavier necessarily, but then like if everything is stiffened up, it's harder to move around, right? Like because you cannot like reposition the limbs, for example, right? Like it's when a person is relaxed, it's easier to reposition their limbs and redistribute the center of gravity so that you can move them around easier, right? But if it's stiff, it's just harder to do that. So I don't know if they actually do get heavier. That's my 2 cents, I guess. Okay, so muscle contraction, right? I was gonna give you a note, but I think I can just explain to you with the diagram here. So first of all, from the nervous system, we know that to move any part of the body, we need to send the signal from the primary motor cortex. So that signal travels down the spinal cord and it's going to exit through the motor neuron. That motor neuron is going to actually form a neuromuscular junction, which is similar to like a neuronal synapse, but this is between a neuron and a muscle. And it's going to connect to a whole group of them. So usually when you produce contraction, a whole group of muscle is going to pull at the same time. So the neurotransmitter that is needed for communication between the neuron and the muscle is something called ACH, acetylcholine. It's the neurotransmitter between neurons and muscle. So ACH allows muscle contraction. Keep that in mind. And the ACH, once it binds to the target, the muscle, it's actually going to cause the action potential to go down the T2-bios. Action potential travels down the T2-bios and trigger calcium to be released from sarcoplasmic reticulum. Okay. And once the calcium goes out, it will bind to the troponin, rolls away the tropomyosin, and then the myosin can grab onto the actin and produce contraction. Okay. So anytime you move the muscle, all these things happen. Let's just go through a few quick conditions here that you might be interested in. Polio. Okay. Polio viruses, they infect and kill motor neuron, causing death or paralysis. If the motor neurons are dead, nothing is communicating with the muscle. And the thing about muscle is if they don't get stimulated regularly, they shrink and then they die off, right? Atrophy. So polio mainly affects children under 5 years of age. 1 in 200 infections lead to irreversible paralysis. And for those who are paralyzed by the virus, 5 to 10% dies when the breathing muscle becomes immobilized. breathing requires action potential to go to the intercostal muscle. And if the communication between the neuron and those muscle is severed because the motor neurons are destroyed, then you cannot breathe. Okay. So there is an effective vaccine available for poliovirus. Actually, in as early as 1988, there is something called the Global Polio Eradication Initiative, or oh, it's right here, GPEI. You can look them up. That was launched, and polio was present in more than 125 countries at the time. Okay, and some estimates say is paralyzing as many as 1,000 children per day. Okay, but because of the immunization effort, that have reached nearly 3 billion children that otherwise might have been infected by the virus. The number of polio incidents actually was decreased by 99% since then. Okay, so in 1988, we're talking about 125 countries being threatened by polio, but since the launch, as of today, it has been reduced to like by 99%. Okay, so as of now, there are only a few countries left in the world that still has polio as like a threat to them. And these includes places like Nigeria and Afghanistan and Pakistan, Pakistan, right? And so people are trying to eradicate the disease. You might remember eradication, where we only eradicated smallpox, and polio is really close. And they're saying, there are only like 4 or 5 cases that has been reported annually nowadays. And if they can just contain the disease and eradicate it through vaccination, then we won't have to worry about polio anymore. Okay, another one is the amyotrophic lateral sclerosis, or ALS. There's another name for it, Lou Gehrig disease, which also kills motor neuron, and the person would become paralyzed as a result of that. This is an autoimmune disease, though. Okay, it's not a virus that you catch. This is when your body turns against yourself. Many of you probably know Stephen Hawking. He had ALS, but he was able to live a relatively productive life despite his disability caused by the disease. There was a Ice Bucket Challenge in 2014. It was 10 years ago, and it raised over $220 million. I don't know if you guys remember that, but people were basically it's like an internet meme thing, right? Like you pour ice water on yourself, and in the process you raise money. I remember our Centennial president at the time. She also participated in this. Okay, botulism. Some bacteria make deadly toxin that disrupt the flow of signal from nerve to muscle. An example of that is botulism, which is caused by Clostridium botulinum. You might not have heard of Clostridium botulinum, but you probably are familiar with Botox. Botox is the same toxin derived from the bacteria, and it causes muscle to become paralyzed, but very mildly, and usually injected under the skin. And the idea is when the muscle of the face here is a little bit paralyzed, then the wrinkles don't show up, right? Because if you wince your eyes, squint your eyes, that's when the wrinkle shows up, right? You move your forehead, that's when the wrinkle shows up. So if you do a little Botox, paralyze the muscle, then the wrinkles are not as obvious. But how it works, that's the bacteria, by the way. How it works is basically the toxin produced by the bacteria will interfere with the release of acetylcholine. So I told you, acetylcholine is the neurotransmitter that allows communication between the neurons and the muscle. Without acetylcholine, you cannot communicate, you cannot contract the muscle, you become paralyzed. Okay, so this actually, like, it's a serious food poisoning. You can catch it from contaminated food. Tetanus is caused by another bacteria belonging to the Clostridium family. This is Clostridium tetani. And the toxin in this case prevents the spinal cord from releasing inhibitory neurotransmitter. Right? So this one, you cannot contract the muscle. This one, you can contract, but you cannot relax. And people get tetanus. There's another name for this. It's called locked jaws. The person is stiffened up, can't relax. And you know, often people say if you get cut by like rusted nail, or if you step on broken glass outdoor, you gotta check your tetanus shot. Okay, make sure you have up-to-date immunization, because the bacteria is actually anaerobic. They live in oxygen-free environment, and you know, a lot of times it could be in like it's the soil that's the matter, not so much the rusted nail so much. This is a famous picture. You search up tetanus online, you're almost always going to get this picture. It's an artist depiction from during the, I think, the Second World War of soldiers getting tetanus. Okay, and they're all stiffened up. Right? Every muscle is stiffened up. You cannot relax. Hence the name lockjaws. Okay, we're just gonna go through, you know, a couple more slides here, 3 more slides here, and then we're done. Muscle fibers, which is muscle cell, right? There are 2 types here. There is what's called like the slow twitch muscle fibers, and then there's the fast twitch. The slow twitch fibers, they are good for endurance activities, okay? Like long distance running or cycling, and they're able to contract for a very long time without getting tired. And these muscle are darker in color. So yeah, that's what dark meats are. The darker color is caused by this substance called a myoglobin. It is better, more efficient in delivering oxygen compared to the regular hemoglobin. So it allows the muscle to contract for a long time without getting tired. So your postural muscle, like the ones in your back, lower back, those are slow twitch fibers. Okay? They are not meant to create a lot of forces, but they could go on for some time without getting tired. Okay, so like salmon, that's like red meat, right? Because salmon swim against the current, right? They can't get tired. They have to keep going. Duck breast, that's dark meat, right? Because ducks can fly. The breast meat is like you flap the wings and then they fly, right? What about chicken breast? What's chicken breast? Is that dark meat or white meat? Do you guys know?
White.
Yeah, that's why chickens cannot fly. Right? The breast meat of the chicken is white. It doesn't have the myoglobin. It cannot sustain long-term contraction. The white meat is fast twitch fibers. They are good for sudden bursts of energy, a rapid movement. Allows the chicken to get out of the way when you try to catch them, I suppose, but they cannot flap it for a very long time. Okay, so some fish, like a tilapia or something like that, that's white meat. Right? They can dash out of the way quickly when a predator comes, but they cannot sustain constant swimming against the current. Okay, so if you are running a marathon, do you need the fast twitch or do you need the slow twitch?
Slow twitch.
Slow
Slow.
twitch, that's right. Okay, and you can train. By training, your muscle ratio will change. It will change from more fast twitch to slow twitch. For a sprinter, though, you will need more fast twitch, right? So it's not this or that. Right? The ratio can change. Okay, that's it. Which protein covers binding sites on actin? Well, that would be the tropomyosin. The troponin controls the positioning. Which neurotransmitter is needed for muscle contraction? If you're paying attention, you will know it's acetylcholine. All right, that is all for today. Please do your quiz. Next week we will this week is already week 12. So yeah, so this week, week 12, we will we only need one lesson for the reproductive system. Okay, we're gonna do it on Wednesday. Next week we'll do the next week is week 13 already. We will do the last lecture, and then that will get us ready for the final test, final exam. All right. Okay, thank you. That's all. If you have any question, feel free to ask. Otherwise, see
I
you
have a quick
Wednesday.
question.
Yeah, go ahead.
I was looking for the lecture notes from the last lecture, as well as the study guide answers, and I haven't been able to find them.
Okay, let me just double check that after we
Okay.
leave, and then if you still have trouble finding them, please email me again. Okay.
Okay, thank you.
Okay. Bye bye.